How about 150? Now this is important, all right? I want you to think about this. What is the probability that you're going to live to be 150 years old? Well, let's, in the traditional sense of, you know, you're here. Okay, you're talking to people. Well, maybe you're not talking. Yeah, we won't, yeah, let's not say you have some like frozen version of yourself. Yeah, no, just like you're, I mean, we're contributing to society or doing. Yeah, what's the probability you live to be 150? 0? What do y'all think?
How many people have done it?
Has anyone done it?
I think so.
Nobody's made. Okay, so let's make this so it's not debatable. How about 300?
No, that's just plain dead for.
What do y'all think? What's the probability somebody lives to be 300? Can we say 0? This is the part that I'm trying to get you to understand. Nobody's ever made it. Does that mean it's not possible? It may not.
What is technology?
Still like maybe that 0.001 maybe.
Okay, look, we cannot say 0. All right? Just because an event has never occurred does not mean it cannot occur. All right? Now the probability is what we consider, we actually have a word for it, all right? Words to describe how small this number is. We say it's infinitesimally small. We're talking like 0.00000000000 with a little 1 at the end. Infinitesimally small probability that this is going to happen. But you can't say 0. You can't. Just because it hasn't happened. Look, the sun came up this morning, right? Which means the earth is still turning and the sun is still where it has normally been, right? Everything seems pretty normal. Okay, how many days has the sun come up on this planet? If you believe in some sort of evolutionary thing, then it's billions of years, right? Which is a lot of days. Does that mean the sun's going to come up tomorrow? Well, you hope it does, right? But it's not guaranteed. It's not guaranteed, right? Something could happen that would cause a major problem, right? So all I'm trying to say is just because something happens all the time does not guarantee it's going to happen. And just because something has never happened doesn't mean that it won't. Let me give you an example that makes I hope will make a little more sense and help you believe that can't be 0. Has anyone here ever played like the Mega Millions lottery? Did you win? No, you're still here, right? Okay, right? Okay, did you the Mega Millions? Okay. Okay.
If you won, would you still be teaching?
We need to talk about how much. But I mean,
like the highest jackpot in history, would you still be?
no, I wouldn't. But at the same time, you have to, even if you're like rich, you still have to find something that motivates you to get up every day and do something. So, yeah, I don't know. Okay, whatever. So look, what's the probability of winning the lottery, the Mega Millions? Are they good odds, small odds? They're small, right? Okay, so let's say that you play the Mega Millions lottery, or somebody plays the Mega Million lottery. The probability that they win it is small. What's the probability that they play it 2 weeks in a row and hit it both times? Even smaller, right? What's the probability that they play it every week for 52 weeks and hit it every time? Can you say small? I mean, can you say 0 though? Is there some chance that they could hit the lottery every week for 52 weeks? I'm not saying can they do it. I mean, like, you can't say 0 though. You can't. Like, everyone always says, when you play the lottery, you can't win if you don't play, right? If you play, you can win, and it is possible to win 52 weeks in a row. Infinitesimally small probability. And think about this one. I'll throw one more onto it. What's the probability that this person plays the lottery every week for 52 weeks, wins every 52 weeks, also gets struck by lightning every week, and survives for that 52 weeks? Could it happen?
Sure.
What's the probability?
Guardian angel.
Infinitesimal. So we have functions that do this thing where they have this behavior where they start to go towards a number like 0 here without actually ever getting there. They just get closer and closer and closer and closer. All right? Lines don't do that. Quadratics don't do that. Polynomials don't do that. Rational functions and logarithmic functions do that. And so these two become very important to us, especially like a business model. I'll give you something more applicable. The bulbs up here in the room, if I'm manufacturing these bulbs, I have a lifetime, an expected lifetime for those bulbs, right? And you can look at it as the same model here. What's the probability that when it comes out of the box, it's going to work? Pretty good, all right? What is it going to work after the first year? Or, I don't know, first month? Yeah, it should be working in a month. How about 50 months later? Yeah, pretty good. But what's happening? Every time that light gets used, right, we're decreasing the chance that it's going to burn out. Now, but you can't tell me when. Now, the chance that it's going to work for 300 months or 300 years, you can't say 0. All you can say is that it drops down to basically 0, and right? So businesses like to use rational functions and logarithmic functions. And I've talked myself to a point where I can't even talk about these right now. So let's just go have a good weekend. How about that? Go play the lottery. I want you to sign in, though. We'll do it right here. It's coming around. Go ahead.